Chemistry Chapter 2, Measurement Notes. Table of Contents, Scientific Method, SI Units, Accuracy and Precision, and Significant Figures.
The scientific method is a process that consists of many steps, including observations, questioning, forming hypotheses, prediction, and testing and experimentation.
Observations can be quantitative or qualitative. Quantitative can be measured, while qualitative can be observed.
Okay.
Oh, it's turning green.
Doesn't
Wonder
work
why.
as well as you thought it would.
The qualitative observation that's most obvious here is the color change. The water changes from clear to green. There are many other qualitative observations, including smell, touch, taste, or sound.
This video represents quantitative analysis, since the weight of the subject can be measured in grams.
The next step in the scientific method is questioning. A qualitative question would be a question such as, why did the water turn green? A quantitative question would be, why did the mass increase when the dye was added?
The next step in this process is to form a hypothesis. The hypothesis is a testable statement based on the questions you have previously asked. Our hypothesis, for example, is that the dye dispersed in the water and reflected green light. That is why the water turned green. Or that the mass of the dye was added and therefore the mass increased. The qualitative observation.
Experimentation must be done using correct laboratory methods to test the hypothesis in a correct manner that results in correct answers, and not misguided ones. Our experimentation was to observe that the dye alone uses color to identify whether or not a reaction has occurred. When the dye changes color, that means that a reaction has occurred. If nothing happens when dye is added, that means you did something horribly wrong.
The final step in the scientific method process is to revise your hypothesis. After testing your hypothesis, revise any discrepancies you found to form a theory. A theory is a broad generalization that explains a body of facts or phenomena.
SI units. The International System of Units is used by most scientists around the world. For this reason, it has been adopted as the standard of the world. Few countries have not adopted this standard, one of those countries being the United States. Gray and black countries on this map have not adopted SI yet.
Units. The standard units of measurement in SI are used for quantitative measurement, such as the kilogram for mass and the meter for length.
Here are some of the prefixes and symbols used in the international system. Accuracy and measurement. Accuracy is being very close or equal to the accepted value. The following video demonstrates darts that are accurate due to their close proximity to the center of the target. In this demonstration, notice that all the darts are in the center of the target.
Precision. Precision refers to the closeness of a set of measurements to each other. The following video demonstrates darts on a target that are precise due to the close distance between them, but are not accurate because they are far from the center of the target.
Significant figures are a method to determine how precise your measurements can be.
When taking measurements and calculating figures from those measurements, significant figures must be taken into account. An end product must be only as precise as the least precise measurement. For example, a team is only as strong as its weakest player. Here is a visual representation of why we need sig figs. This graduated cylinder measures in increments of 1 milliliter. It is less precise than this graduated cylinder, which measures in increments of 200 microliters. Therefore, this graduated cylinder is more precise because it measures in smaller units than this graduated cylinder. Ta-da!
Variables with infinite significant figures. If you have a quantitative value of whole numbers, such as 2 beakers or 3 test tubes, these values have an infinite number of significant figures. The reason? No matter how many decimal places you add to the number, it is still the same value. 2 beakers is still the exact same as 2 beakers. Therefore, the value 2 beakers has the ability to hold an infinite amount of significant figures.
Rules for determining sig figures. All numbers other than 0 are significant. All of them. No exceptions! And all is quiet on the course.
Determining significant zeros. Zeros appearing between non-zero digits are significant. Sandwiches are significant. Example 2.304. The zero between 3 and 4 is significant. The number has 4 sig figs. Zeros that are in front of any non-zero number are not significant. Example 0.00234. The zeros are not significant because they aren't in a sandwich. They are sitting in front of the non-zero numbers and are only there as placeholders. This number has 3 sig figs.
Continued. Zeros at the end of a number and to the right of a decimal point are significant. For example, 4.2000. The zeros are significant because they come after the decimal point and the end of the number. There are 5 sig figs in this number. Zeros at the end of a number without a decimal place are not significant figures. They are simply placeholders. Example 2000. The zeros are not significant because there is not a decimal point. There is only 1 sig fig in this number.
Continued. Zeros before decimal place are significant. Remember, the decimal place has to be present. Example 2000. Period. The zeros in this number are significant because there's a decimal place ending in the number. Therefore, this number has 4 sig figs.
Ready? 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 Shush. Oh wait, it's already recording.
Just leave it on.
Okay, go.